Now we'll practice using lookup tables in the back of your textbook, or its electronic equivalent. There are multiple ways to determine properties of substances, but one way that often comes up, believe it or not, even in the 21st century, is physical tables of properties. So for example, let's imagine that you know the pressure and the temperature of some substance, and you want to know something like specific volume or specific enthalpy, or maybe even some quantity we haven't gotten to yet in this course. Sometimes you just have to open a book and look them up. We'll also deal with electronic methods for retrieving this information, but for now, let's practice using the tables since the concepts are very much the same. So let's say that our specific goal in this problem is to sort out the phase and the specific volume of water at a temperature of 200 degrees Celsius and a pressure of 10 bar. The very first thing I would do before trying to appeal to the lookup tables would be to just sketch out TV and PV plots just to get a sense of what we think we're looking for. First, we'll sketch out a TV plot. Remember, those look something like this, and the gray area is the vapor dome. An isobar on a TV plot that passed through the vapor dome would come up from the left, go horizontally through the vapor dome, and then curve up to the right in the superheated vapor region. Let's assign a temperature of 200 degrees C to that horizontal section in the vapor dome, so I'll draw a black dashed line to represent 200 degrees Celsius, because ultimately that's the temperature we're interested in. Now, if we specified that temperature, it would be reasonable to try using our lookup tables to look according to temperature to see if we can find a pressure of 10 bar and then see what phase the substance is in. Over on the right, I'm going to show you a screen capture of the electronic version of our book where I do exactly that. So let's open the book, and I'll go to the table of contents first, go down here, and we scroll through almost all of the book, all of the chapters, to get to the appendices, and the first thing we want to see is the index to tables in SI units. There are so many tables in this book, there's an index to the tables. Now we're interested in water. So if we look, table A2 refers to water, as does A3. A4 is superheated water, then there's compressed water. This one's saturated but is solid vapor, we probably won't use that too much. So I would say, since we're interested in the temperature of 200 degrees C, let's start with table A2, the temperature table. And this is way too small to read. It has a column of temperature and a column of pressure, but I'm going to zoom in so that you can actually read this. So let's scroll down in this table until we find a temperature of 200 degrees C. So I'm going to scroll down, and the idea is when I find that temperature, we'll be able to see the corresponding pressure in the vapor dome. So here's the temperature. This column, just to be clear, the second column is the pressure in bar. So we look down and we see for 200 degrees C, the pressure is 15.54 bar. Alright, we have our first data point, and there's a one-to-one correspondence between the two because remember, inside the vapor dome, we're on that horizontal line, so there's only one pressure for a given temperature. Let's write down that data point now. So I'll write that up here. According to table A2, at 200 degrees C, the pressure is 15.54 bar, and that corresponds, again, to this region that I've just highlighted in yellow. Well, great, except that we're not looking for that pressure. We want a pressure of 10 bar. So what looking in that table told us was that the isobar we've drawn here corresponds to a pressure of 15.54 bar. The isobar that we're interested in, corresponding to 10 bar, would have to be lower, right? It would have to be somewhere down here, and it would have to intersect the 200 degree isotherm, the horizontal line on a TV plot, over there on the right in the superheated vapor region. So automatically, just by looking all of this up, we've discovered that this point right here, that I've highlighted in yellow, corresponds to a superheated vapor. We've determined the phase of the substance. So we at least know that it's superheated vapor, and we know that we should look in the superheated vapor table for water. Before we do that, though, I want to show you how you could have reached the same conclusion if you had decided instead to use a PV plot and to look up a pressure of 10 bar first. So let's do that. A PV plot looks like this. There's the vapor dome. And remember, an isotherm on a PV plot comes down and to the right and then slopes downward in the superheated vapor range. Let's draw in an isobar, which on a PV plot, remember, is a horizontal line for 10 bar. And now we'll go through exactly the same exercise. We'll look in the index to tables first. And we do that, but now we want the pressure table. So that's table A3, it's water, the pressure table. And we'll look up 10 bar. Once again, I'll zoom in so that we can see things. And now, over here on the left, we'll look up the pressure. Temperature is second column, so we scroll down until we get to a pressure of 10 bar. Right here, again, there's a one-to-one correspondence inside the vapor dome because this is for the saturated state. And we see that the temperature that we find is 179.9 degrees Celsius. Well, we can put that up here. So at 10 bar, we know the temperature. We've just essentially looked up the isotherm that we already drew. And remember, that corresponds to the temperature right there. It's inside the vapor dome for this table. So if that's the case, we can label this isotherm 179.9 degrees C, but now we have the same issue we had with the TV plot and looking up according to temperature. We want a temperature of 200 degrees C, so clearly the isotherm that we're interested in has to be higher than the one we looked up inside the vapor dome. It would have to do something like this, and then it would intersect our 10 bar isobar over here to the right in the superheated vapor region. So once again, we conclude that water is a superheated vapor at 200 degrees Celsius and 10 bar, and now we've seen how to do it using either a TV or a PV plot and two different tables in the back of the book. Now we're not quite done yet. Remember, the other goal was to determine the specific volume of water at that temperature and pressure. So to do that, we'll have to actually look in the superheated vapor table. So we're going to open that up. And this one, you can see, is table A4, superheated water vapor. That's what we're after. Click on that. These tables are interesting. They're arranged according to pressure primarily and then temperature secondarily. So we want to look up a pressure of 10 bar. This is temperature over there. So to find the pressure first, we look in all of the table headings. The pressure is increasing. 5 bar, 7 bar, 15, I overshot. There it is, 10 bar. So this is the correct pressure, 10 bar. The temperatures are over here on the left. And we already know that the saturation temperature is 179.9 C, but we're interested in 200 degrees C. Now, to find the specific volume, we look up, and this column is specific volume in cubic meters per kilogram. Great. So we scroll back down to the appropriate pressure and temperature, and we get our answer. The specific volume is 0.2060 cubic meters per kilogram, so we managed to find the specific volume at this temperature and that pressure. According to table A4, it's this value. Now you may not have realized it, but we lucked out. The table actually did contain an entry for the exact temperature and pressure that we were interested in for water. There will be times when we're asked to find some temperature or pressure that is not listed precisely in the table. There's ways of dealing with that, and we'll talk about that in another video.